The following podcast is sponsored by Structure Tech.
Building science is a little bit more complicated. People are like, well, what is that? Like, don't we already know what it is we need to know about buildings? They seem so simple. And people are sort of surprised to learn that there are people who specialize in the layers that separate the inside from the outside and build them and design them so that they're durable and efficient.
Welcome, everybody. You're listening to Structure Talk, a Structure Tech presentation. My name is Bill Ulrich, alongside Tessa Murray and Ruben Saltzman. As always, thanks for joining. On today's episode, we are absolutely delighted to have Christine Williamson with us. Christine is a building scientist by trade, yes? Yep. And we're going to dig into your life, your career, how you got to where you are today. And we're just super, super excited to have you here. So Christine, could you take a minute and just kind of introduce yourself and tell us a little bit about you?
You're correct. I'm a building scientist. When I used to fly places and I was on airplanes and people would ask me what I would do, I would not say building scientist, because then people are like, oh, well, tell me more about that. So if I did not want to have a conversation, I would just say that I was in the building industry or I was in architecture broadly. And then they don't ask any questions. They're like, oh, okay, that's great. I know what that is. Building science is a little bit more complicated. People are like, well, what is that? Like, don't we already know what it is we need to know about buildings? They seem so simple. And people are sort of surprised to learn that there are people who specialize in the layers that separate the inside from the outside and how those layers ought to be arranged to get the best out of our buildings and build them and design them so that they're durable and efficient to operate, but also efficient to actually build. We don't want to use too many resources to build buildings. So how can we make the best use of our resources and find our sweet spot for risk and durability and aesthetics and performance? And there are people like me who specialize in exactly that. And sort of one of those things, I constantly am impressed with this when I hear about somebody else's job, where I'm like, oh, that's really, yeah, that makes sense that someone would do that. But you just don't think about it. It's kind of, now, of course, I can't think of a single example, but I feel like I've had that experience, probably all of us have, where we're like, yeah, all right, somebody does need to design such and such, or somebody does need to be thinking about whatever it might be.
Tessa, I want you to jump in, because I've often asked you, like, how does one wake up, as a child, they're 5 years old, and it's like, I want to be a building scientist. When did that light bulb go up for you, Tessa? And Christine, I'd be curious if it was similar. I mean, how do you decide one day just to get into building science?
Boy, I didn't even know what building science was, like Christine said. It's just most people don't. And so I just kind of accidentally fell into it. I've always been interested in houses, and I always thought, well, I should be an architect. And I thought that was the direction I was going to go in. And then after doing AmeriCorps after high school and working for Habitat for Humanity building houses, then I started to kind of reevaluate that decision and exploring other options. And that's when I ran across the building science degree at the University of Minnesota with Pat Hellman, which I think, Christine, Pat.
Fantastic.
He's so great. Yeah. And I thought, you know what, this is fascinating. Like, there is this whole other world out there that looks at how buildings, how all the systems fit together, how they work, how one thing impacts another. And we need to be thoughtful in how we design and put these buildings together so we don't have failures. And it's about energy efficiency, durability, occupant, health and safety, comfort, all of these things. And it's like, yeah, it seems like that's just so basic, right? Like, whoever's building our houses, they should already understand that, know that, and do that. But in reality, it doesn't happen, right? So yeah, I'm curious, Christine, explain a little bit how you got into this, because I know we haven't mentioned this yet, but you have a pretty well-known building scientist in your family, right?
I sure do. But I think actually people end up discovering this for themselves, like any career path for the most part. So my father is Lstiburek, and he has been a great mentor and teacher throughout my career. It's a special thing to be able to learn from your father and relate to your father, not just as a dad, but also as a colleague. And I've come to appreciate that a lot in my adult life and in my sort of more adult practice of my profession. But really similar to you, Tessa, in that when I think most people approach building science as a tool to solve specific problems. You don't come to it with this abstract area, like I want to study this field of science, the way that you might if you were in school and you were like, well, I really like biology, I want to be a biologist. Or, I mean, actually, it's a little bit like engineering. I want to be an engineer. Okay, well, there's a lot of different types of engineers. Like, what kind do you want to be? What kind of problem do you want to solve? And I think that's really the case with building science. And for me, I thought I would go into just normal architectural practice. And when I was in architecture school, I took a job with a fantastic architect in New York City, Chris Benedict. And she designed extraordinarily energy efficient buildings. And I found working for her that if you want to accomplish anything extraordinary from an energy perspective, you have to understand building science. This field of knowledge has a name and it's called building science. And it's not just building science, but it's also construction. What are the actual methods, the means and methods that we use to physically put things together? There's a sequencing, there's a division of labor among different trades. No single person knows how to build a building, which is amazing to me. No person on earth knows how to build a building. And yet we build them all the time. And it's this sort of magically collaborative process that nobody has full ownership over. Everybody owns their little part and it comes together to create sometimes really extraordinary things. But we have problems in those divisions. So how do we kind of how do we take the best stuff out of that collaborative effort, and how do we avoid some of the big pitfalls? And the field of study that investigates that is building science. You have to know about thermodynamics, you have to know about construction. If you want to do anything cool with buildings, you need to know these things, or somebody needs to know these things.
Gosh, I love how you said that, Christine. It really, like, the art of building science is understanding all these different systems, how they fit together, so that you can kind of solve these problems without creating new problems, really.
Or creating new problems that you know about and you're prepared to deal with. And
Yeah.
I think that's I think a lot of times when people approach this profession, because they don't have a language to really speak about it. So the language that we use a lot of the times is just very simplistic. It's, well, what's the right way to build and what's the wrong way to build? And I want to learn the right way and avoid the wrong way. And unfortunately, that's too simplistic an approach for much of what we do in construction. The truth of the matter is that we're really weighing a lot of competing goals that are all legitimate. And we have to decide how to prioritize among competing goals. And building science is a tool. It doesn't tell you how to build your building. Building science doesn't care. It doesn't care what you do. It just is. But it is a tool that helps you understand risk better, performance better, and it helps you make decisions so that your building most closely reflects what you value and what resources you have available. So to give an example, like, we value energy efficiency. We also value comfort and aesthetics and budget and cost, right? Like, we don't have unlimited resources to build everybody's houses. If we built everybody's house like the Palace of Versailles, there'd be a lot of homeless people. It would be an inefficient use of resources to build all houses like castles. It would also be similarly uncomfortable or not good, not efficient in its own way to build all houses like warehouses or like tents. We don't want to do either of those things. So how can we understand materials better and performance better to make the best use of the resources that we are prepared to devote to something? And that is a much more complicated question than, well, tell me the right way to do it and I'll just do it the right way. Unfortunately, what a lot of people want to know, a lot of our clients want to know, right? Like, we'll just do it the right way. What do I pay you for? Do it the right way. Design my windows the right way. Well, okay. I mean, what kind of windows do you want? You know, when we say your windows shouldn't leak, what do we really mean by that? Like, it's a much more valuable discussion to have, okay, under what conditions will this window leak? And under what conditions should it not leak? Rather than, well, just give me a window that doesn't leak. Well, it's going to leak. I mean, we're not building a submarine. And people who do build submarines, they, x-ray all of the seams and they're welding stuff together. And like, we're not doing that. So, okay, so what's the next best? It's a tool, I guess, not a specific instruction manual or a list of rules.
My guess is when either of you two are at a dinner or having drinks with people and you're in their home, you are the center of conversation because everybody's coming to you with their problems and be like, why is this happening? Do you find that to be true? Where you're always solving somebody's problem when you're in their home?
So this is I'm going to answer this with a very feminine comment here. I don't know if you are aware, but there's a romantic comedy called 27 Dresses. I forget how many dresses.
Yeah, it is.
And it's this woman who is always, the story is that she's always a bridesmaid, never a bride kind of thing. So she's been a bridesmaid in 27 weddings and had 27 awful dresses. I remember there was a season of my life where everybody I knew was getting married. So there were lots of weddings. I feel like the past 2 or 3 years, everybody I know all of my friends have bought houses. So I've had, what does this house report mean? Is my house going to fall down? So yes, I do get a lot of questions about that kind of stuff, but it's such a pleasure. I love knowing something useful enough to actually help people that I care about, making big decisions about what for most of us is our largest single investment. That said, it truly is a pleasure, but I couldn't, some professions like lawyers or doctors, it would drive me crazy to get like, can you just look at my elbow, please?
Yeah. Well, on that topic, I gotta push down that road a little bit because that's what we do. We're home inspectors, and day in and day out, we're helping people with those decisions. So I gotta ask you: is there any type of house that you would never buy? I want to know what you like in houses. What about? Let's just start with new versus old. I think we actually did a podcast on that topic specifically where we argued about it. I'd like to hear your thoughts on that.
I'm firmly in the old camp, and I'm in the almost anything is fixable camp. I'm in the what do you want out of this camp? And I think actually that's why the home inspection stuff is so important on the front end, is that people, and it's very difficult because homeowners and prospective homeowners they're naturally very emotional about this big purchase. And I don't think it is particularly helpful to tell people, well, just approach it like a business. Don't be emotional. They're going to be emotional. So that's okay. I think we kind of have to work with that. But I do think it's helpful to set realistic expectations for the kind of living environment you're going to be in and what the maintenance requirements are going to be for that. And I think some people, especially people buying new houses, assume that maintenance should be zero and that nothing should ever go wrong and whatever. Yeah. Older houses, maybe you guys can comment on this more. I'm sort of curious to hear what your experience is, but I would imagine that newer people buying a new home are potentially very unrealistic about what they expect to see. And people with older homes are like, yeah.
Oh, definitely. Right. Some of the most incompetent homeowners I've ever seen are the people who buy brand new houses. Yeah. By far. They know they're incompetent. And then they make this assumption that, well, then therefore I should buy a new home because I don't have to do anything. But the one thing though, I got to know what you say about this. Why old? Is that because they're more durable, more forgiving? How come?
Personal preference. I guess I just like the character of it. And I'm attracted to the idea of the house sort of always being a project, always being something that you're working on. And it's a way to connect. Maybe this is super cheesy, but I guess it's a way to connect one generation to another. I love that the house that I'm in had people living in it who I don't know, and they cared for it and brought it to today. They cared for it sufficiently to bring it to today. It's a nice example of improving things incrementally and truly incrementally. Like this house will never be finished. There's a poetry to that, a beauty to always contributing to something's betterment, to never really being there.
What I think is really cool, Christine, is that yes, you have this one foot in the very scientific, the engineering world of understanding building science and the thermodynamics of a wall system and all these things. But at the same time, you have an appreciation for the artistic side of houses. And the aesthetics and the history and all of that too. And does that come from your background? You started out in architecture, right? And then you kind of evolved into building science, or?
Yeah, I mean, I still consider what I do to be architecture. I say building science to accurately describe it day to day, but I view building science as a part of architecture. And maybe that's me just flattering myself because I love architecture. So I'm like, yeah, I'm one of you. But I do think that it's just a part of architecture. And so maybe a little bit, but I think also it's just from being human. You experience a house in all kinds of different ways, and we all have a connection to our living space. So when I bought this house that I'm in right now, it's an old Craftsman. It was built in 1936, I think. And the first thing I did was renovate the kitchen. I mean, and also I didn't even know how to cook at the time. I do now. It was, which was sort of a funny prospect. I realized that I could have eaten out every single night of the first year and spent less money than I did on the renovation. But it's an open floor plan and I love the kitchen and it's gorgeous. And I don't regret having done the kitchen before insulating the attic. But,
what would your dad have said?
I know, right? I didn't ask his opinion on this, but I think he would have said, he's a kind of buy the shoes kind of guy. So I think he probably would have been pretty supportive either way. Actually, he probably would have been like, just do both, do everything. But which is the danger when you're in this industry. Like my poor husband, I talk about houses being a project, like they're really a project in the Williamson family. The site. But no, people are they're making decisions in the context of the rest of their lives. And I think that's helpful for every profession to know about. We have a tendency to sort of elevate what we're good at or what we know a lot about. But the reality is we're all whole people and we have lots of things that we care about, not just one thing. So it leads to some potential irrationalities, I guess. But that's life, right? It's a little bit messy.
So could you tell me a little bit about your journey through your career? So you were in school and you hooked up with this company and you were looking at what types of buildings, and then how has that shifted over time?
So I was in New York City and I was looking at primarily multifamily buildings. And I was working for a straight up architecture firm. Now it was a firm that cared a great deal about energy efficiency and construction. It's kind of a neat firm, actually, if you're unfamiliar with the owner of it, Chris Benedict, really neat lady. She's an architect, went to Cooper Union, New Yorker through and through, and is a very passionate environmentalist. She's also a pretty passionate libertarian and believes that if we as a country, as a society, are going to make any kind of long-term environmental advancements with the way that we build, whatever it is we're considering should be financially viable in its own right. So she was very much in favor of finding clever ways of doing things as opposed to just throwing money at something to make it more energy efficient. You can save energy in the long run by spending more money up front. We know this, right? You can buy solar panels, you can buy more insulation. Chris's real passion lay in finding out how to save energy and doing so without additional upfront resources, or by being really clever about how you're using what you've already got. How do we work with what we were already doing to maximize performance? And she's very good at it. So her buildings used at the time, she's probably even better now, but they would use 85% less energy for heat and hot water than a typical New York apartment building. And she would do it for no extra upfront costs.
Oh my gosh.
Which is incredible. It's and she knew these are not modeled savings. This wasn't from an energy model. This was she would look at part of hiring Chris meant that you gave her your utility bills. So she would look at the utility bills and she cared immensely. Like, did I actually succeed in doing this? Anyway, so I had a great time working for her. She taught me a lot about the practical aspect of building science and design. So this is the stuff that we design in the office, but this actually goes on a building. So we have to make sure that these two things agree with each other. If you can't draw it properly or model it or whatever, someone's not going to be able to build it. So she would have us do really like hands-on things. I was an intern. There was another intern I worked with who was also great. But Chris would do stuff like we proposed like a ledge on one of our buildings. This doesn't have to do with building science, but it's cool. Chris was like, no, that's not going to work. That's going to be a spot for pigeons. It's just going to be awful. And we're like, nah, I don't know about that. It's not that big, whatever. So she had us go out and like look at pigeons in the city. She said, go outside, spend the day, look at these pigeons. So we were looking at pigeons, and she had us model a pigeon, like out of paper and the ledge, and see if the pigeon that we had modeled met the sort of fatness of normal New York City pigeons and would fit on this ledge, stuff like that. She also hauled in one of those window units off the street, air conditioning systems that you see.
Yeah.
Someone had discarded it, and she hauled it in. This was actually my first day. She had hauled it into the office, and it was on my desk. And she said, okay, I want you to learn everything you can about this. I want you to take it apart, put it back together, find out where its center of gravity is, draw it, draw every part of it. Like I want you to be an expert in this window unit, because she wanted to use it in a building, and she wanted to know everything about it. So that was the intern's job. So she was, anyway, very, very practical minded, very much figure this stuff on your own, spend time on construction sites, watching the trades work, figuring out where you might be able to find efficiencies and areas where it's not practical to ask somebody to do something different, that kind of stuff. Anyway, all that's to say is I loved it. I mean, who wouldn't love that, right?
Wow.
It's my job. I mean, maybe some people wouldn't, but it's my job to go look at pigeons for the day. Like, what? I had friends who were like stuck behind a desk working at Goldman Sachs, and here I am making like paper mache pigeons. Anyway, I had the time of my life. It was fantastic, and a real neat way to see how the intersection of a bunch of interesting stuff, construction, design, and business too, and science, all kind of neat things coming together. Why is it that we build the way we build? Is a really interesting question. And then with respect to, I mentioned before that she's a very passionate environmentalist and also a libertarian. I find this endlessly interesting to this day, identifying things in our industry that are seemingly inefficient that we do all the time. So we know how to save energy there are a lot of things we know how to do, and it doesn't cost extra, but we're not doing them. Why aren't we doing them? Like, these are interesting questions, and it's not because we don't want to, it's just fascinating. There's thousands of things that seem irrational at first, and then you look into why it is we build certain ways or why we do things the way that we do, and it's just neat. Cool.
Because it's the way we've always done it. You just keep doing it that way.
Yeah, and I think actually that's part of it. I think the term in economics is called path dependency, and I see it a lot in construction, where even if you could come in out front as an outsider in an industry, say you're some sort of financial consultant, and you could go to a big production home builder and say you would save X amount of money. Actually, framing is a good example of this. Like standard framing and advanced framing. It's more efficient to use what's called advanced framing, so you're spacing your studs further apart. It makes more room for insulation. You use less wood overall. You engineer the building in a particular way to use less wood. It's not more complicated. What it is different. And even though something can be less expensive in terms of materials, not that much more complicated to actually install. I mean, once initially a framer learns this, it's not hard, but we have this incredible dependency on how we've done it before, because there is this sort of hidden cost in learning something new, and risk. There's risk in learning something new. Mm-hmm. So how much money are you really going to save? And how much money is each individual player involved in the decision going to save to make the change worth it? So consequently, there's tons of buildings that we don't do advanced framing for when we could. And it wouldn't cost us more money, but we don't, because there are sort of hidden risks with it that don't have to be there, but are. Mm-hmm. It's crazy. And there's thousands of examples like that, where because it's the way we used to do it actually is sort of weirdly legitimate reason, not to change. Mm-hmm. Sometimes it's not. Sometimes it's like, yeah, okay, figure this out now. But other times, like, people are busy. They've got 1,000 other concerns on their list, or 1,000 other reasons why they might get a job versus their competitor. And it makes more sense for them to devote more intellectual energy to marketing than to hiring more advanced framers.
Sure.
There's trade-offs involved in everything.
I love what you just said, because it really, I think after 2020 and everything we went through in our business, we've talked on previous podcasts about a lot of changes we've made this past year. And it's been like changing our report writing software, changing our client attendance policy, changing our training process. And it takes a ton of energy and thought and time and even risk to make these changes. But it was a great opportunity to make those changes, because change or die, really. you have to adapt and grow. We saw the long-term, benefits of doing these things. We may not see the payback right now, but it's thinking down the road, and we can do the same thing with our buildings.
You're totally right. I think also this period has revealed a lot of inefficiencies that we kind of took for granted before and provided an opportunity to correct some of them.
Yeah.
I hope that stays, and that's a lesson that we can kind of continue with. But
yeah, change is constant, right?
Yep.
Learn to embrace it.
Yeah.
I got to ask you something, Christine. I want to ask you about why we build some of the buildings the way that we do and some of the design, because it's a frustrating topic every time we're teaching a class. But before we get that, for anybody listening, I want to back up a little bit, kind of to the very intro of who you are, because I want to let people know that you are qualified to answer this question. So first off, how we found you, your name came up. It's crazy how things happen. Your name was sent to us like 3 different times in a 2-week period. Like, hey, have you checked out her Instagram page? Look at all this stuff. And you've got a wildly successful Instagram page. It's what is it? Building Science Fight Club?
Building Science Fight Club. Yep.
Yeah. Like over 62,000 followers on there. Crazy. You've got some fantastic illustrations and explanations. I mean, if anybody's interested in that kind of thing, check her out. You're also, I've got here, you're a member and former chair of the ASHRAE Technical Committee on Moisture Management in Buildings, which, I mean, that's a pretty big deal. If somebody is an authority on moisture management in buildings, I might come to you. I might come to you for these types of questions. So it's to say you're not some schlub off the street answering this right now. But you know what? Hold on. Let me take a left turn here real quick. Where'd you get Building Science Fight Club? What is that all about?
The name kind of started as a joke, honestly, and now I can't change it. It's sort of funny, I guess, to this day. Some people take it a little bit too seriously, where they're like, she really wants us to duke it out here. No, it started as a bit of a joke. My background is in architecture, and a lot of my classmates from architecture school really had very limited experience on job sites. So I mentioned my first job with Chris Benedict in New York City. I was spending a ton of time in the field on job sites. That's really atypical for most people who graduate with an architecture degree and then go and pursue licensure working for an architecture, for a traditional design firm. The amount of time they spend on job sites is just not a lot of time. And it's difficult because they don't really have a lot of time to spend on job sites. They've got design work to do. So I recognized that I would get a lot of questions from classmates from architecture school who were advancing in their career, and they were getting to have leadership positions in their firms, in their respective firms. And it was sort of a bit of the emperor has no clothes experience for them, where they sort of assumed that they would get that this information would come to them somehow as they advanced, and they realized, yeah, I don't know the answer to these questions. So I don't know if what my contractor is telling me is true. Should I listen to this? Should I accept this substitution request? Like, what's reasonable? What's not reasonable? And so I'd get those questions because they trust me, right? We're friends. And it's also easier to ask questions to somebody that you know and likes you when you're not doing it in front of your client or your boss. I started the Instagram account. I would take photos on job sites and I would just mark it up. Like, I'd draw on the photo and be like, this is the flashing, this is the window return, or, really pretty basic stuff, but technical stuff. And it was for people I knew. It was for actual friends. And then it just grew from there to their friends. And then now it's people I don't know. But it is sort of funny that being popular, having a popular Instagram account in this stupid time we live in is its own credential, which is funny to me in that I've certainly become a much better teacher from teaching on Instagram, because I got to kind of crowdsource some of my teaching technique. Really, when I teach something, anytime you teach something, if you're live, you get better at teaching. And Instagram, going through the discipline of posting something every week, has certainly been helpful. It's made me better at being a teacher. It's also made me better as a building scientist, because I get more from comments and questions from people who have experiences of their own to share. I get to sort of fine tune my own knowledge based on other people's experience too. So that's been good. However, I'm not good at what I do because of Instagram, like because I have a popular account. But because I have the popular account, people hear about me. You mentioned that I chaired an ASHRAE committee. A lot more people know Instagram than know ASHRAE. So having 62,000 followers on Instagram means something to more people than, well, she chaired an ASHRAE committee, which is, for better or worse, that's the world we live in. So it sort of makes me laugh a little bit that I'm still the same building scientist I was a year ago, 2 years ago. Instagram hasn't made me the expert. I knew this stuff independently, and Instagram means other people know about it who may otherwise know about it. But it's a really weird world where that's the case. Anyway, it's been fun to do. I really do enjoy it. There's some sort of constraints to the medium that have really made me a good teacher, in that you're limited to 10 photos at a time or 10 images at a time. So how do you communicate something complicated in only 10 images? You have to distill something down to its most important parts and choose what not to communicate. And that's a challenge, but it's a good one. It makes me a better teacher. And I think it makes people learn better in the long run too. I mean, it can't be the only thing, right? It's like, flashcards for memorizing things back when you were a kid in school. Like, you still have to learn your multiplication tables, but these other exercises can help you be better.
You know what though? I was just going to say, Christine, like, I love how you explain these really complicated, like, building science ideas in this, like, more like basic step-by-step approach. Like, you figured out how to translate these complicated concepts and make it easy to understand, I think. And I don't know of any other, like, building scientist who's really been able to do that. Usually, like, you got a question about something challenging and you have to read this long, like, research paper on it, right? Or like Google all these different opinions on it. And, like, you're making it so that you can, like, look at a few different pictures and read a few different bullet points and understand the complexities of it.
You don't understand all of the complexities of it, but I think that's how it started. The benefit of having had the account start for friends. So it's kind of like, I view it like, okay, we're in college. You've got an exam the next day. You blew off every lecture because you were totally into some boy. And now your roommate is telling you, look, I took the class last semester. We're going to stay up all night and you're going to pass the stupid exam. What do you need to know to pass the exam? And I kind of view it like that. Like, each specific thing I post on has volumes written about it that you could go research if you wanted to. But ultimately, you're going to have to take an exam. You have to make a decision. So you're going to need to know a few key things before you decide to crack open all these other textbooks. That's what I try to do with this stuff. And I think this is why a lot of other building science education has failed, architects in particular, is that the teacher has, whether they really realize it or not, what they've done is they've essentially said, I'm smart and this is my judgment on this issue, and you should therefore you should trust me and make the same judgment. And that's right. Most people who teach this stuff are also consultants, and that's the job of consultants. They consult. And they have an area of expertise and they're asked to provide an opinion, and you listen to them because of their authority as consultants. But that's not really helpful in teaching. And in teaching, my goal isn't to say, well, you should listen to me because I'm an authority on this. My goal is to say, okay, you need to make a decision on this issue. I'm not your consultant. So you need to make this decision. And here's the information here are the types of things you're going to want to know for you to make this decision. And you have to decide, okay, so I'll say, so what's the issue with how to install your windows? Like, what kind of window detail should you draw? Okay, I can't tell you. I don't know you. I don't know your building. I don't know your project. I don't know your long-term goals. But here are the things that you're going to want to pay attention to. And you can go from there. Like, you decide how durable this needs to be. You decide, is this a passive house, or is this sort of an investment property that needs to perform to code and maybe a little better, but we're pretty good with that. And that's a different way of teaching, rather than just each time kind of being a consultant and saying, well, in this case, this is what you should do. I think a different approach that's also explicitly risk oriented, which I think you guys might be able to relate to very well in your capacity, where you're providing guidance that has to do with people make decisions related to risk. Like how much risk are you comfortable with in this, and how much and what resources are you willing to devote to this particular issue to reduce that risk? And that's a very different way of teaching somebody, because you're equipping them to make the decision. You're not making the decision. You're not telling them what to decide for them, because you can't. Like I don't know for someone else what you value. Like I was talking to someone earlier who has asthma. So he and his wife are going to make different decisions about indoor air quality or construction related to indoor air quality in their home than someone else. And we talked about old houses and new houses. So for somebody with an asthmatic child or somebody who has asthma in the family already, you're going to value different things. And so maybe it does make more sense that you pick a newer house that has had a blower door test, and you know what the air tightness value is, and you make decisions to control these variables. Maybe you make different decisions if you're buying a duplex as an investment property and it's older and you've got a whole bunch of repairs to make, and the air tightness is not really at the top of your list. So you make different decisions. But how do you have the information? What you need is the information to know how to intelligently navigate that. And that, again, we live in a really sort of polarized time where it's, I think, difficult for people to appreciate that there can be legitimate competing interests, and these competing goals can all be legitimate, but that doesn't ease the responsibility of having to decide what to do with limited resources. So indoor air quality is really important. So is energy efficiency, but so is supporting your family. So is not taking a loan for an investment that you can't pay back. Got to weigh these things, and they're all legitimate, but the person who's best positioned to do that is the person who's making the financial decision themselves. So how do you equip that person to make the best decision? Don't make it for them.
That conversation feels very applicable to our industry.
Yes.
Right? There are so many people who wear the shoes that Ruben and Tessa wear, and they go out and they want to just project their opinion onto what somebody should do. And I've argued kind of endlessly that it's not up to me to tell them, should you buy this house or not? I'm just going to give you the tools you need to make an intelligent decision. And you're going to have to decide what's good for you. And that leaves people standing on a firm foundation. The buyer, the realtor, the homeowner. Now we don't have to accuse or put people on a defensive posture. We can just get together as a group of people and be like, this is really important, and this is why I'm deciding that I'm going to have to move on, or this is why I really need you to fix that, or whatever it might be. But it's not adversarial. It's just I'm kind of giving you a framework for you to think through that's going to be useful for you.
Exactly. And I think a lot of times when it's framed in that way, people actually really appreciate it. So this was a potential new construction job, and the family wanted to build a pretty large house. If I'm remembering, it was 8,000 or 10,000 square feet. And they were talking about, but this has gone a little further, and they were talking with their architect about the specific systems in the house. And the architect had talked to me and was saying, well, we can't really afford to condition the attic. I want to have a vented attic, but the roof line was really kind of complicated. And my answer was like, no, you're choosing. This is a choice you're making. You're choosing to invest to invest the money in the size of the house. And you're doing so at the expense of the performance in this area. And that's okay. You might want to make that choice, but it's helpful to actually frame it to use the framework of choice, as opposed to sort of these, like, viewing these things as like unnatural constraints that are being imposed upon us by external forces. Like, you get to choose. So I would encourage that client to have to pursue a more, and I get this all the time, particularly with sort of the in-between clients, like the clients that are not quite like crazy wealthy, but can buy a house that looks like they are. And there's this tension. It's like, well, I can't afford to do it that way. Well, maybe you'd be better served adjusting your expectations a little bit. We can get the acoustic performance you want out of your house and the energy efficiency and indoor air quality things and stay within your budget if we build a 6,000 square foot house instead of an 8,000 square foot house. Or if we renovate your existing house, as opposed to, knocking something down and building something brand new. But the framework of choice, I think, is really helpful for people. But it's also things that people run away from too. I'm not sure psychologically why we do that, but maybe because the home buying process or the home building process is so intense, and there's just the sheer number of decisions makes people
It's
overwhelmed.
overwhelming. Yeah.
I find that it really is important to think about it in that way, rather than this sort of, I'm being forced into this and it by unfair forces.
Mm-hmm.
Christine, are you working more with single family houses now? When you left New York, did you kind of leave that building design that you were working with?
Actually, so I was working on mostly multifamily when I was in New York, actually all multifamily when I was in New York, so apartment buildings, and they were typically mid-rise, so nothing high-rise, mostly mid-rise construction. And then after that, I was working almost exclusively in commercial and institutional buildings, so like hospitals and big stuff, really big stuff, which was really cool. I saw a different part of the industry than I see now. And now in my practice in private consulting, it's almost all residential, like single family homes and renovations and that kind of stuff. So it's I've gotten exposed to a lot. What's sort of funny and as a consultant on the building science consulting side, there's kind of a perception. Yeah, I think this is a sort of a general perception that commercial consulting or those commercial projects and institutional are really the height of the profession, and that like the real building scientists are working on the tower projects and stuff. But I have to say, I believe residential construction to be much harder because in commercial construction, there's more specialization, and residential single family homes, there's more of a jack of all trades mentality. And you really do understand the house as more of a system. So you can be a consultant like me in commercial construction and never have anything to do with the mechanical system at all. You can know nothing about mechanical systems and have a rich, fulfilling, and interesting career in just the building enclosure, the layers that separate the inside from the outside. You do not have that luxury in residential construction. You have to know everything. And actually on the home inspection side, you really have to know everything. So I remember looking at my own home inspection report, and there were some comments on like the water heater, and I was like, I don't know, or like the electrical panel, or I mean, and it's sort of funny. And sometimes people ask me questions like that because they hear building scientists and they think that means I know everything with buildings. And I'm like, I don't know why your sprinkler system's not working. Like, I can't fix your plumbing problem. But in residential stuff, the burden is much greater in that the people that are in the residential industry that make our design decisions and construction decisions have to know a great deal more about adjacent trades than their counterparts in commercial construction do.
Now, around that, you got to answer me this. This is one I've been dying to ask. As home inspectors, we don't get to see all the layers behind a wall. We don't know how they wrapped everything behind the siding and all that. All we get to do is look at the big picture, from the street. Where does all the water end up? And then that's where we focus our efforts. That's where we push, prod, poke, use a moisture meter. We really dig in on those areas where water gets concentrated. And you go to houses maybe about 30 years old and younger, and they all seem to be designed pretty much the same way. It's you take all of the water at the front of the house and you make a bunch of funnels with valleys on your roof, and you direct it all right to the front door or up against a wall or a window.
Yeah.
Why do we do this? Why is this done? Please help me understand.
It's funny too. I think people just don't realize how many resources they actually have at their disposal, particularly with water management. I like to teach this way a lot when I talk specifically about leaks, and that you actually have to have 4 conditions. 4 conditions need to be satisfied before you have a leak. 1, you need a source of water. 2, you need a pathway for that water to travel from where the water is to where you don't want it to be. 3, you need some sort of driving force or pressure or something that pushes water along the pathway. And then 4, you need something to get damaged as a result. So something needs to be moisture sensitive, or somebody needs to get annoyed. Something has to happen as a result of this. And the reason I like to teach about leaks in that way, because people are like, yeah, I know what a leak is. I don't need your help to let me know more about that. But I find it really helpful to point those 4 things out, because it also lets us know that there are 4 avenues that we have at our disposal to address issues before they become problems or even after the fact. So we can practice, for example, one of the ways that we can address leaks is through source control. So direct the water to some place that's safe, like a drain slope the site away from your building, have good site drainage. Source control is enormously helpful. What we tend to focus on is just pathways. So let's seal the pathways and stop all of the leaks. Now, sometimes that's effective, and I'm obviously not going to say that you don't need to worry about making sure things are sealed in your building that ought not be sealed. If it's raining out and your window is open and you're getting water blowing inside, close the window.
Yeah.
Just to start. But focusing so much on the pathways, I really think leads us to discount these other resources that are available. For instance, source control, and then reducing the pressures or the forces that drive things through our buildings. That's a little bit more of a complicated conversation, but that's a big help. If we have walls that drain properly and systems that drain the way they're meant to drain, pathways become less important. And then seal everything that you can seal. And then when appropriate, use materials, build with things that are not as moisture sensitive. Now, we can't always do that, right? And again, these are, what do you do with limited resources? What combination of those 4 approaches do you take in any given case? The answer is going to be different. And this is why every building is different. You're going to navigate that slightly differently. Suppose you don't want to, that poor drainage method. Suppose there's some architectural reason why you really want to collect the water that way, or you think that roof line is really helpful or whatever. Well, now you're going to need to make other decisions that will compensate for that decision. So for example, if you want a really modern house with no overhangs and you want the real clean lines and edges, well, okay, now you will be pretty well served to, instead of using OSB for your sheathing material, switching to plywood, or instead of using a textured building wrap, using an actual drainage mat, maybe spending a little bit more money on a fluid applied membrane or an integral sheathing plus water control layer in the wall assembly rather than just a typical tar paper or something. Maybe you spend some more time detailing your windows differently because they're not inset, they're this sort of sheer exposed face. And it's okay to do that, but it's helpful when you have an awareness of these things so that you know where your risks are and you're able to make those decisions more intelligently. I think people are most scared of risk that they don't know about, right? It's like, what am I doing right now that's risky that I don't even know is risky? If you understand the risk, people tend to be much more comfortable with that. Like, oh, okay, that seems reasonable to me. I'm going to drive my car on a sunny day when the roads are clear and it's not a lot of traffic, versus like driving your car through a blinding thunderstorm or something. That's a little silly because it's sort of a more obvious. The risk you're taking is more obvious. But suppose you have to make the decision to go out in your car and you don't know what the weather is outside, or your pilot doesn't know what the weather conditions are before taking off. I mean, that would be absurd. We wouldn't do that. So similarly with design, we want to know where our vulnerable spots are and design accordingly and make trade-offs. It's always trade-offs.
What percentage of houses are actually designed by an architect as opposed to just grab this plan off the internet? It was $49.95 and we want it to look like that.
Oh gosh, like a tiny percentage. I think the estimate is like less than 2%. It's hard to actually calculate. It's hard to calculate, and I'm not sure what the numbers are, but a very small percentage of homes are designed with architects. It's funny, I had, when I was I think I might have still been in architecture school, a former colleague gave me a book of house plans and was like, this is what you're going to be doing or something. And I looked at it and it was just laughable because it was just floor plans. I was like, yeah, it's okay. It's a little bit more than this, but that's, to a lot of people, that's what they think design is. And I guess that's fine. They haven't thought too much about it. I occasionally get those requests too online where someone's found, they're like, yeah, we already have our plans, but it's, $49.99 off the internet PDF plan. It's like, you still have a lot of decisions to make.
You get what you pay for. We'll just start with that, right?
Yeah,
you get what you pay for.
Actually, I think a lot of times people are pretty lucky. They get a lot better than they pay for without realizing it. And then they complain.
Yes.
I think a lot of times, a lot of the problems that I see on the forensic side, so investigating things after they've gone wrong, is really not so much failures, but the consequences of bad decisions voluntarily made. And I feel bad for people who end up in that situation. Obviously, you don't want anybody to suffer, to pay more money, to be in a difficult position. But it's also, I don't think that it's really fair to describe this as sort of being the victim of unforeseen events. These aren't like, yes, a tornado comes by, unforeseen event. There you go. But you build a modern house without an architect, and now you've got rotting walls and rotten sheathing and curling baseboards because you neglected to hire professionals. I'm sorry that this has happened to your house, but you decided to economize on intelligence and expertise. And this is what happened.
So I have to jump in. I mean, we could do this all day. I'm thoroughly entertained right now, and it could go on forever, but we don't have all day. And Ruben, Tessa, do you always feel like we're just scratching the surface of every conversation? You know, when we have to actually cut in and be like, okay, we got to put on a boat. Can we have you back? Can we talk more? Because it's just like, okay, we just opened up. Now we're starting to get to the good stuff.
This stuff is my jam. I love it. I love talking about it. I love talking with people in the industry. Everybody's got their own stories to share. One thing I guess I get asked a lot is, people want to ask this, but they don't because they're too polite. But they're like, okay, so I understand that you make recommendations on people in terms of, you tell them how to build stuff so that they avoid problems with their buildings. Well, how do you know? Like, how did you come to have that information, to know what to tell them? And you get that information by learning the general principles. So you have this framework of general principles, like gravity acts down, and this is how the way construction sequencing works. And you get that general understanding of the industry. And then you populate that framework with tons and tons and tons of conversations like we've had right now, and more so you populate that framework with experience, your own experience and the experience of your peers who say, and it's like a series of, well, I did this and then this happened. I did this in this environment and this is what I think happened. And you hear that and you just get better and better. So not only do I like talking about this stuff, but talking about this stuff makes it helps us calibrate our own sense of where we are on that risk scale of like, well, this is really, really, I feel really safe recommending this option and less safe with this option. The more conversations we have with people with different experiences and different climates and different building types, the better we get at this. So it's very, very fun.
I love that.
And thank God for the internet, so we can share these experiences more efficiently. How did this information get distributed back in 1976?
I mean, they had to like write books and stuff. It was crazy. But it's sort of funny. I think my husband pointed this out to me the other day, that this is what they kind of promised back in the day. This is what we thought the internet was going to do. Like, oh, you can read every book. Like, you have access to all these books and libraries across on the other side of the world. Instead, we use the internet for like Facebook and cat videos and stuff like that. Go figure. But I mean, we also do stuff like this, which is really kind of neat. I think in a lot of ways, we're reaching kind of a really exciting time in the building industry where we have this unprecedented ability to learn from people in different places, and not just in North America, but across the world. And I hope it really benefits people globally. Actually, I think in North America, we're really pretty good at framed construction, and they don't build that way everywhere yet. They build a lot of heavy masonry buildings, and they're very good at it. A lot of places, not everywhere, but some places they're really good at this stuff. But framed buildings are different. And I hope that our experience in North America, not only do I hope we get better at it, but that we save a lot of other places the heartache of the misallocation of resources.
Sure.
The consequences of voluntary bad decisions that we see all the time.
Hey,
the world
Christine.
needs more building scientists, bottom line, right?
That's right. Obviously.
So Christine, can you tell everybody where we can find you on the web?
You can find me on Instagram at Building Science Fight Club is the name of the account. But again, not literal, no actual fighting. Everybody be polite. It's sort of funny. The account has just gotten big enough that I think some people are there's just surprised that it's not personal. Like I don't talk about my personal life in it, but it's personal in that I'm a real person and I answer things and other real people answer. Anyway, so people can find me there. Feel free to participate in the conversation. I post once a week. And so the best time to get online and participate in the conversation is on Saturdays. And I hope I continue to do that. And then other than that, don't find me. That's it. I'm in Dallas. That's it. You can can come find me in Dallas. But
that's awesome. Thank you so much for your time. Like I said, we're just getting going, and hopefully we can do this again, and we can kind of get into the details of the house that I'm going to be building, because I have a lot of questions. So.
Yeah, I'd love it. Anytime, guys. It's this was super fun and super easy to set up. So
awesome. Thank you.
Sweet. Thank you.
Well, everybody, that's a wrap on today's episode. You've been listening to Structure Talk, a Structure Tech presentation. My name is Bill Lstiburek, alongside Tessa Murray and Ruben Saltzman, the three-legged stool that occasionally gets wobbly. Thanks for listening, everybody. Talk to you next time.
For more information on how we can provide you with the right information about your home before you buy or sell, contact us at structuretech.com.